All right, this video is going to cover the Maze Practice Quiz 2, and I'm probably going to sound like I'm talking really fast because I'm going to try to get through this as quickly as possible because I missed the last question on the last practice quiz, which was a database quiz. Anyway, so you've got this block code right here, and it is the fill pixel method, it looks like. Fill pixel, row, column, color. It lights up the pixel at the given row and column with the given color specified as a string. The top row is row 1. And the leftmost column is column 1. So we've got and I'm gonna again use my drawing tool. We've got a grid that's 7 by 7. So maybe I'll just draw it way over here and see if I can do this. Three, 4, 5, 6, 7. Excuse me. 1, 2, 3, 4, 5, 6. Okay, cool. So let's go through this. We've got row num, and I would, if this was me and this was my test in front of me, I would be writing these variables out. Okay. Row num's 1. Num pixels is 1. And we were going to have a call num at some point. So it says repeat this whole thing 3 times. So this is an example of a nested loop. It's asking you to do this 3 times. So you might also want to do the same kind of thing that I did before with outer and inner loop to count where you're at. And I might pause the video if that sound keeps coming on. Hopefully it stays off. I tried turning off all my processes but anyway, so 3 times. So this first one's going to be the first time I go through it. So column num is equal to 5 minus the row num. Row num is 1, so this would be 4. Okay, so column num is 4, and so it repeats the number of pixels. It's going to repeat this 1 time. So it's going to fill row num, which is 1. Col num is 4, and we're going to fill it with green. So row num is right here, and column is 1, 2, 3, 4. So that's getting filled with your green color. Okay, so it just based on that, your answer is C. But let's just keep kind of going through here, okay? So then what we do is we do 1 plus 1 for col num. Col num becomes 4 plus 1 is what, 5? Okay. So we just did this 1 time. Then what we do is we add 2 to num pixels. So num pixels becomes 3. And then row num becomes 2. We add 1 to it. And then we go back up and we repeat our outer 2 times. We did our inner once. Because num pixels was 1, so that was done. Okay, so then we do let me see here, column's 5. So then anyway, we have 5 minus the row num, so col nums become 3. Num pixels is what, 3, so we're going to do this first. We're going to do this one 3 times. So we do row num is 2, col num is 3. So then we've got row 2, then column 1, 2, 3. So we fill that in. Okay. Then col num becomes 3 plus 1 is 4. Okay. and then we got to we had to do this 3 times, so we just did it once. Now we're going to do it 2 times the second time. So then we've got row nums 2, column is 4 this time, so 1, 2, 3, 4, and that gets filled in with green. Then we got to do this our 3rd time. Well, wait, before we do our 3rd time, we have to do col num, which is 4 right here. 4 plus 1 makes it 5, okay? So then we're going to go through our 3rd time through here, and so we're row 2, then column 5. 1, 2, 3, 4, 5, and we fill that in. C's looking real good right now. We got the first 2 done. Num pixels becomes 3 plus 2 is 5, and then row num becomes 3 because we got 2 plus 1 is 3. And then we got to go through our 3rd time, our outer loop. Then we do 5 minus the row num. Row num is 3, so 5 minus 3 is 2. Okay. Then we've got our row number's 3 and our column number's 2, so 1, 2 right here. Okay. So we're going to do this basically 5 times, so sorry I did that there. So that was the first time through. And then we got to do 2, 3, 4, and then 5. Okay. So we did the number 1 time through there. Then we do column num, which is 2 plus 1, so it becomes 3. So then we go back up for our 2nd time through, and row 3, column 3. 1, 2, 3 right here. Then we got to do our 3rd one right here. 3rd time through. That was 4, so 1, 2, 3, 4. We got to do our 4th time through. This becomes 5. 1, 2, 3, 4, 5. When we get to our 5th time through, this becomes 6. Okay. And then our 3rd time's done, and our outer loop is finished, and our answer is definitely C. Okay. Okay, next up. So, let's see here. It says, which set of code will move the robot from start to stop and end facing the correct direction? The robot may not move into gray blocks. So again, I would just test each of these. So this one says move forward. That puts me there. I'm pointing that way. Move forward. That puts me there. I'm pointing that way. Move forward. Puts me there. I'm pointing that way. Rotate left. So now I'm rotating left. So now I'm pointing that way. Move forward. I'm right there. Then I gotta rotate right. So I'll get rid of that and then put that up here. So I'm rotating right. Then I move forward. Rotate left. I'm gonna get rid of that and rotate it left. And then I'll move forward. Move forward. Move forward. Rotate left. I'm going to get rid of that. Rotate left would make me like that. And then move forward. So A is your answer here. And I'm going to pause the video because I don't want this sound to go in. So if you hear some sort of choppy thing, that's because of that. Okay, so this next... let's do this. This next example, number 3, it says, a program races 4 avatars, pink, purple, pie, hopper. So this is pink, purple, hopper, and spunky. And these are their programs next to them. So after the first 3 repetitions of each loop, which avatar will be ahead? So we're doing this 3 times. So 1, 2, 3. This is pink. So Move is 1, and then we add 1. So the first time through, we move 1, so pink goes there. And then we add 1 to move, so move becomes 2. So then we go, so the first time you go 1, and then you go 2, because 1 plus 1 is 2, so then you go 1, 2, and you're right there. And then for the third one, you do, 2 plus 1 is 3, so I'll do 1, 2, 3, puts me at 6. Let's see here. Purple, for the first one we go forward 1. Then we do, for the next time through, 1 times 2 is 2, so then I go forward 2. And then for the third one, I do 2 times 3 is 6. No, 2 times 2, sorry, which is 4. So 1, 2, 3, 4. Hopper, see, I'm gonna have to get out of here. So either way, this is 6 and this is 7. We'll have to memorize that, okay? So 6 and 7. And I will move, down on this so we can see the next 2 that we can run. So let's do that, full screen. All right, so then we got Hopper. We got, again, let's do 1, 2, 3. Hopper moves forward 4 spaces first time through, so 1, 2, 3, 4, so he's right there. And then you do 4 divided by 2 and you get 2, so then he moves forward 1, 2. And then we do 2 divided by 2 equals 1, so he ends up right there. So that's 1, 2, 3, 4, 5, 6, 7. So there's 2 of them. This guy right here, the purple guy, was at 7 as well. So this one's at 7 and this one's at 7. And last one we start at 4. So we move 4, 1, 2, 3, 4. And then, so that's 1, 2, 3. So we move 4 there. And then 4 minus 2 equals 2. So we go forward 2. And then we do 2 minus 2 equals 0. So that's where he ends up. So which one will be ahead? E, 2 of the avatars will be tied for the lead. So Hopper and Purple up here will be tied for the lead. All right, next up. The grid contains a robot triangle. It's initially pointing left. The robot can move into a white or gray square, but cannot move into a black region. The program below is supposed to get the robot to the gray square. Does the program get the robot to the gray square? So, again, let's do this. So move forward. So there. If can turn right, it can rotate right. So I'll do that. I'll rotate right. It's pointing that way now. Move forward. Okay. And that if statement's done. So there's no loop or anything. So that's where you end up. Does it get you to the gray box? Nope, it does not. Okay. Okay, I'm running up against some hard time, it looks like here too, so I'm going to try to go through this one real quick. So you're going to need to pull this bottom part up while you're watching this video, but you basically repeat until it hits the gray. There's an if-else statement inside, so if you can move right here, which you can't, so it skips that if part, but then it goes to the else. Inside the else, can it move right? Nope. So, but can it move forward? Yes, so it goes there. Okay, then it can't move to the right, so it gets to the else part, and if it can move right, it can't, so if it can move forward, it does. Okay, then we get to, we got to repeat again, if it can move right, which it can, Then what it does is it moves forward and rotates right. Okay, sorry about that. I had to start a new video. But what I was trying to say was, so you can move forward right here, and it says if you can move right, which I can, but then it says move forward and then rotate. Well, I can't move forward here, and so I'm basically stuck. That's where I get stuck, so B is your answer, okay? So that's number 5. Okay. I think the rest, 6 and 7, you guys can do those on your own. I don't need to demo those. But I should probably talk about databases. That's kind of important. So a school keeps a database for all its students with a great variety of information. A small part of the database is shown below. Right now, the concern is senior finals exemptions. Seniors must have at least an 85 GPA. Additionally, they must have less than 3 tardies and 0 suspensions. Currently, the program can only sort 2 of the categories in the database. So you've got absences, tardies, grade, suspension, and GPA, and you can only do 2 of those. You can only sort. A decision must be made how to sort the database for maximum efficiency in determining exemptions. What will the first sort be? So senior finals exemption. Seniors must have at least an 85 GPA. Okay, sort by absences and then sort. First of all, I think what you probably would want to do, okay, so the first one, sort by absences, and then second, sort by tardies. The biggest thing would be to sort by the grade the kid is in. You don't want to do this sort including freshmen, juniors, or seniors, so I would just get rid of the grade. So that would narrow it down to only 1/4 of the school. So again, with databases and these type of questions, you just kind of almost have to think through what would be the fastest way to sort information and data. Again, we're talking about just the senior class. So so to me, A wouldn't work because I wouldn't want to sort by absences and tardies. GPA, again, I don't like that because I want to sort by the students, like what grade they're in. Right here, I want to do that first. So to me, A and B don't work. Let's see here. C and D then. You could sort by grade and then by tardies. Let me think here. They must have less than 3 tardies and 0 suspensions, but they first need to have their GPA. I don't know. I would do D because you're sorting by GPA and then grade because that's the main thing. They must have at least that. That's the first thing they wrote about, and that they're seniors. So I don't know. C works. But ideally, I think you want to sort by, well, first I would sort by if I were to do it, I would do grade and then GPA, because then that would cut down on the number of people. You would force them just to do seniors, but I don't know. C would work, but D is a better answer, I guess. So pick D on that one. So, all right, this video is done.